it's a real pleasure. I hope you're seeing my screen with our wonderful colleague and friend, Andy Israel. This is really the kickoff to the Andy Israel Memorial Fund, and where we're going to offer pilot awards for the study of posterior cortical atrophy. And the reason for this is the great generosity of the Israel family, who, in memory of Andy Israel, have started a fund along with all of his friends. There was just a huge outpouring of support regarding this effort and this memory of Andy Israel. Just a little bit about Andy. He really was the quintessential physician and family man, I think. I mean, reading his obituary, which I hope you'll get a chance to look at, he truly was able to show tremendous care to his patients and to his family, and a tremendously respected San Diego physician. He was, if you see all the things that he's done, he's basically been the top doctor, voted every year since 2004 until his retirement in 2013, and really was an absolutely outstanding diagnostician, and really such a fantastic and caring person. I was honored to be able to meet him because Sarah, his daughter, was in my lab, and so I was invited to the house, and it really was a fantastic, warm feeling there. And Sonia Israel, who's also in attendance here, esteemed physician, faculty member at UC San Diego, and just really a warm family. And we're just honored to have this talk in his memory, and also to kick off the Andy Israel Memorial Fund, which is going to offer pilot awards, and we're shooting for about $10,000 just to kick off some ideas. And this is an endowment, so this will be a continuing pilot award opportunity for our community to look at. Posterior cortical atrophy would be the ideal topic to hit, but we also think that regional sensitivity to neurodegeneration, because it's such an odd factor of this posterior cortical atrophy, and why this illness impacts the posterior cortices rather than the typical regions of the brain. This is something very important to understand. I think it's going to give us a lot of insight into the progression of Alzheimer's disease. And we have some great strength here at UC San Diego, and we're looking forward to gathering a discussion group and thinking about the ways that we might be able to tackle this illness. And so as we think about that, I want to it's my honor to introduce Sebastian Crutch, or Seb Crutch, who is a professor in neuropsychology at the Dementia Research Center at UCL, at the very esteemed Queen Square Institute of Neurology, world-renowned center. And Seb focuses on rare and young onset dementias, and particularly interested in visual impairment in posterior cortical atrophy. So he leads the rare dementia support group, which is a fantastic way to provide care and support and advice to people living with rarer dementias, and has been running a research program looking at the impact of support groups that bring together peer and professional experience. So we thought that this would be a fantastic way to kick off the Andy Israel Memorial Fund and the opportunity for studying these rare and young onset illnesses. Unless perhaps Sonia or Sarah, if anybody wants to say anything.
I love that.
Okay,
absolutely.
Great. Go ahead.
All my love, sweetie, and I'm here.
Okay. Oh, sorry.
That was my sister. Yeah. So thank you, Jim. We're all very excited to have Seb speak to us. I know this is going to be a great kickoff. We're looking forward to having people apply for the pilot funding and to get more research going, because as you probably already know, or will soon hear, there's so little is known about PCA that it's time that we try to move the research forward. So thank you for doing this, and thank you, Seb, for being here.
Great. Well, thank you so much for the invitation. I never sadly had the chance to meet Andy, but I have had the pleasure of meeting Sonia in London. And so it was really touched to be asked to come and speak to you all today. And as I think the title suggests, I'm very much a psychologist by background, and have all of my experience, everything I know comes from the people I work with, and who very kindly shared their experiences, their challenges, their uncertainties, and their questions with us as we try to understand a little bit about this unusual condition. And so just before I tell you a little bit about what I think PCA is, or what other people have told me it is for them, I thought I'd just make a couple of quick general points before I start, if that's okay. And one of which is to say that in today's talk, I'm going to be trying to tell you about where the start of the ideas for several of our research projects have come from. And so I hadn't understood fully the nature of the funding scheme, but I hope it's particularly well suited, given it's a pilot funding scheme, that really what I want to be telling you about today is not just the outcomes of our research or even the hypotheses we were trying to test, but to dig back a little bit further and say, well, why were we asking those questions in the first place? What is it that drew us to explore in this particular area? And of course, that frequently comes down to things people living with the condition, or those nearest and dearest to them, say or observe or reflect or are concerned by. And this is something we've tried to, in our group, make as explicit as we can. I'm not trying to knock formal forms of patient and public involvement, committee involvement, reviewing paperwork, etc. But often it's the greatest ideas come from those unplanned encounters, those serendipitous comments. And I say this coming from a group which was really founded around the discovery of the first gene for Alzheimer's disease, which came about when a family member wrote to Martin Rosser, who started our group, and our geneticist colleague John Hardy, to say, I think you might be interested in my family. There seems to be this pattern of Alzheimer's running from generation to generation. So that's very much how I've been sort of brought up, if you like, that approach. And so I'd like to tell you about a few encounters and people that have inspired ideas that I've been involved in. And the other general point was just to say, I'm going to be talking, of course, lots about PCA, but it's just a reminder that visual impairment, by which I mean cortical visual impairment, impairment of the brain's ability to interpret the information coming in from the eyes, is not just affected in people with PCA. Of course, it's a factor, an increasingly recognized factor in Alzheimer's disease and a number of other dementias. And these visual deficits can arise in PCA, of course, is the presenting symptom often, but in other people, they follow behind a number of other cognitive deficits. And so visual impairment in dementia in general, but particularly in memory-led Alzheimer's disease, is often very under-recognized. And so some of the challenges and uncertainties that I'm going to be describing to you in the context of PCA today, I think it's worth mentioning, might well be experienced by other people with memory-led Alzheimer's disease and other conditions, but perhaps at a time when those people aren't able to communicate so very clearly as many people with PCA do of these experiences, and of the unsettling nature that they have. So that's just a little reminder. And of course, visual skills, absolutely critical, possibly more predictive of quality of life sometimes than memory. And just to make it personal, of course, my understanding that vision and dementia had anything to do with each other didn't really come from book learning. It came when I had the great privilege of working with this gentleman, William Utemolen, a renowned artist, when I was very first in the group as a very green, wet behind the ears research assistant. This gentleman had been diagnosed with Alzheimer's disease in 1996. At that point, he'd stopped painting, but one of my lovely research nurse colleagues, Ron Isaacs, had encouraged him to take up his brush again. And over the following 3 or 4 years, he painted this extraordinary series of self-portraits, which told me much more about the experience of living with a dementia than any of the lectures or brain scans or textbooks that I'd read about. And I particularly remember the experience of Bill being in our centre, and we asked him to draw in the bottom, somewhat curious, I think, by whether these were spatial changes in his art that were intentional and reflective of his experience, or a consequence directly of these visual problems. And we asked Bill to draw a man. And what he produced, as you can see, was infinitely more stylish than anything I could ever muster. But when he completed it, he said, no, there's a problem there. But he couldn't quite spot what the problem was. He couldn't tell that both arms were protruding from the same shoulder socket. So for me, I'm not saying in the forms of art, that all of these visual changes were necessarily that some of them couldn't have been a matter of artistic intent, but at least some of what we're seeing here, I think, is a direct consequence of a blunting of the tools of the artist, of those abilities to see what and where. So just to start where we always should, when we're talking about PCA, with the wonderful Frank Benson, who described a series of 5 people who had come to his cognitive clinic, and where he, as many great clinicians do, and I understand Andy was a great diagnostician as well, started to detect patterns. And so this is one brief description. If you'll indulge me, I'll just read to you, even though you can read perfectly well for yourselves. A 64-year-old former bank executive presented with episodes of anxiety that complicated a slowly progressive disturbance of vision and language. About 8 years earlier, he had noticed difficulty reading. He remained at his job, but his secretary had to read to him. Although still able to write, he could not read what he produced. Eventually, he also lost the ability to write and had difficulty finding his way in familiar areas and in performing visually mediated tasks. The problem slowly progressed, and he stated that what he saw disappeared before he could sense what it was. On examination, he was alert, oriented, attentive, and in reasonably good physical health. His manner was gracious, and his insight was painfully apparent. And I think within that description, there are many commonalities with many of the people I've met living with PCA. This insidious onset, problems with seeing what and where, but also with a broader range of posterior cortical skills to do with literacy, numeracy, and other abilities. And of course, the contrast with things like memory, a sense that is not just vision that's being affected, that language is also beginning to become a challenge, but that one's manner, one's personality is very clearly expressing itself despite these problems. And in terms of what's causing this is down to prominent atrophy of the posterior cortices of the brain. I'll show you a few brain images in a moment. And a couple of brief reminders that Alzheimer's disease is overwhelmingly the most common cause of posterior cortical atrophy, but PCA itself is a syndrome. So there are other causes that we'll touch on. But the majority of people we see with this condition are young at the time, most people between 40 and 65 years of age.
Now, I'd like you to look.
Sorry, that ran on a little bit by itself. Just to try and, if any of you haven't met someone with PCA before, I just wanted to show you a couple of videos of people who've kindly agreed to be videoed to explain some of the challenges that they see. And in this first one, you'll see someone being assessed by my dear colleague, John Schott.
My nose. Keep looking at my nose. And I'm going to put my hands out and I'm going to move my hand. And if you see my hand moving, can you reach and grab it? So I'm going to put my nose. There you go. Got it. Well done. Look at my nose. You look at my nose. You find my hand. Can you see my hand moving?
No, I can see your nose.
Can you see a hand at all? Can you see my hand moving?
Is that keeping my...
Yeah. Keep.
Oh, sorry, that has paused itself.
Now, I'd like you to
See if
can you see my hand moving?
Is that keeping my...
Yeah. Keep looking at me. Can you see my hand moving? Can you see my hand moving?
Yeah.
Can you see my hand moving?
Yes.
Grab it
Yes.
for me. Where is it? Where is it? You got it?
God, where is it?
You'll find it in a minute. Well done. You got it. Very good. Well done. Okay.
So this delightful gentleman was taking part in a training video for optometrists to highlight these difficulties. I don't think I need to say too much. I think also watching that you'll understand that this gentleman understood exactly what he was trying to do, what he was being asked to do. I think you'll have a sense that Benson used the word things disappearing in front of one's eyes. I think also you get that sense of things appearing in front of you, that suddenly something you're looking for, which you couldn't see at all, is suddenly detected and then can be one can attempt to localize it. So experience with great good humor, but it wouldn't take much imagination to imagine how incredibly disabling even just an element of this visuospatial difficulty might be. The next brief recording is of someone looking at this picture of Brighton Pier on the south coast of England and simply being asked to describe what it is.
It looks like a park or maybe a station or a building site. It looks a bit like the thing they're trying to elect for the Olympics.
So I'm not quite sure what's going on with my slides. They seem to, I'm not sure if there's some auto advance function that's clicked on. Let me try and restart that for you. It seemed to have full control of them.
It looks like a, or it could be the beach. Because down here looks a bit sandy. Yeah, it looks like Brighton or somewhere like that. So you're looking out at.
Okay, so I think you could detect again in that lady, when I put this picture up, I suspect within a matter of milliseconds, your brain would have been able to detect this was an outside scene, and then that idea would have guided your eye movements around the photograph to try and pick out some of the detail, identify. This lady is is faced with a different cognitive challenge. She's essentially being given pieces of the puzzle and having to stitch them together, and you can make sense of much of what she is saying. For example, when she talks about maybe it looks like a railway or a station, perhaps she's looking at the legs of the pier and thinking they're like the sleepers on a railway line. When she says what they're trying to elect for a little phonological error for the Olympics, maybe she's looking at this dome at the end and thinking it looks like a sports stadium. And it's only latterly that she's able to use all her many preserved skills, intellect, semantic memory, problem solving, and draw together a conclusion about what this scene might be about. So clearly difficulties in PCA with seeing not just where things are, but also what things are. And if you'd like to hear a few more descriptions, there's this beautiful film made by Simon Ball, an animator, in which he's drawn animations based on the experiences of 6 people living with PCA. And I'd really encourage you to take a look. In terms of why all this is happening, as Frank Benson's name suggests, this is down to atrophy at the back of the brain. This is a compression map, a cortical thinning map, where the hot colors indicate parts of the brain which are particularly thin or losing thickness in people with PCA compared to counterparts with memory-led Alzheimer's disease. And the cold areas in blue are the areas where the reverse is true, where people with memory-led Alzheimer's disease have thinner cortex than those with PCA. So you can see this very pronounced posterior, this all in people with the same underlying disease pathology, pronounced posterior gradient to this loss of brain cells. And in terms of the underlying molecular changes, it seems that in most of the studies that have been done to date, if you can see my cursor, if you look at PIB scans, if you look at where the amyloid is, that doesn't really give us this regional profile that we have just seen in the cortical thickness maps. Whereas if you look at FDG scans, or if you look at tau imaging, then you see a distribution of that pathology, which corresponds much more closely to this posterior clinical cortical phenotype that we're talking about, and also as indicated in red, some relative sparing of the areas most typically impacted by Alzheimer's disease in those with the more common memory-led presentation. And sadly, of course, this is also a progressive condition. Now, we don't often meet people in the very, very earliest stages of PCA, but this is one gentleman who we did purely by chance. He was participating as a control in a subjective memory-led experiment at our department. Thought he'd come as a control, then said, well, maybe I'm a bit concerned about my memory. So joined as a sort of worried well participant. And actually over the following years, what you saw relative to this baseline scan in 2004 was a progressive deterioration of the posterior cortices in these voxel compression maps shown in blue. And you can see the gradual progression of his different cognitive complaints, and notable perhaps that the first time he actually failed any of our verbal memory tests was much later in 2011. So as I say, very much a relative, not complete, but relative preservation of memory compared to these more prominent perceptual and other cortical and visual deficits. And that holds true across a much larger cohort study led by my colleague Kia Yong and another colleague called Nick Firth, looking at the progression of atrophy in different brain regions over time. So really pronounced occipital and parietal loss in these individuals relative to a relative sparing of more traditional AD regions such as the entorhinal cortex and the hippocampus. I spotted, as we were starting, wonderful Doug Galasco in the meeting with us, so great to see Doug. And Doug was one of many people who contributed to this effort. So talking about the inspiration of people living with the condition, this first consensus criteria for PCA emerged when we were having one of our support group meetings, and one of our carer members, having heard that PCA was called different things in different places. Some people call it PCA, some people call it Benson syndrome, some people call it biparietal AD. And this guy stood up really quite cross and said, "Don't you guys even talk to each other about how to define these things?" And we admitted we hadn't done enough of that. So we got together this group involving Doug and tried to define two different levels, really. A syndromic level, where we could define the typical attributes of PCA, but also a classification level which was more related to the actual diseases underpinning these conditions. And the thickness of the lines here indicates that Alzheimer's disease is by far and away the most common cause of PCA, but there are these other conditions, particularly Lewy bodies, corticobasal degeneration, that can underpin PCA. And we, of course, keep our eyes out for occasional and rare other causes of PCA as time goes by. And I really wanted to make this discrepancy because of, for some, in some contexts, drug trials, it's absolutely critical to know this disease level information, whereas in other contexts, such as particular behavioural therapies, or visual aids or environmental changes that you might want to offer someone, then this syndromic level descriptions might be adequate. And also just to encourage you, I suppose, that yes, we do absolutely have much to learn about PCA, but I think it's really helpful that in the last not so many years, atypical variants of Alzheimer's disease, of which PCA is the most common, but where there are also linguistic and behavioural dysexecutive variants, have been increasingly recognised and incorporated both into clinical and also research diagnostic criteria. So hopefully more people are aware that these variants exist and are on the lookout. So for the remaining time we had today, I hoped it was okay, as I mentioned earlier, to talk a little bit about through a few individual stories that prompted different areas of our research. And I hope I've just tried to choose, obviously not a comprehensive account. Forgive me that this is rather biased towards our experience in London, but of course many other great examples across the world, which are being increasingly shared through initiatives such as the Alzheimer's Association Professional Interest Area in Atypical Alzheimer's Disease, and other collaborations. But just a few stories I wanted to highlight as an example of where the ideas come from. So one simple one to start with, just because it was the first person I ever met with PCA, was I remember a very excitable neurologist bounding up from clinic to say he'd just met a lady who had green hands. I was obviously intrigued enough to put down my sandwich and say, what are you talking about? And the story was that a lady who had just seen in clinic had been telling him how she had been sorting out her bedding at home. She'd been smoothing out her red bed sheets. And after doing so, she'd looked at her hands and they'd been bright green. And of course, all of us have, for a brief period, a complementary colour after image when we stare at an intense colour and then look at a neutral background, for example. But in this lady, it was really pronounced. And as eccentric and odd as this might seem, she was really perturbed by this. But it's a great example of where things which weren't in the sort of diagnostic list to start with can enable us to enrich the description of PCA and help people to know what to look out for or what not to dismiss. And in the many years since that first observation, we've met so many people who have talked about abnormal washes of colour late night while driving as being an early thing they noticed, and also really perplexing experiences which might cause you to misunderstand what something is really about, what's the really underlying truth of it. So always remember one lady who made her husband think that he didn't know, that she didn't know when she was in the year. He thought she was disoriented in time because she looked at trees in the middle of summer, bright green leaves, and said, "Oh, what a lovely red colour, it's lovely, it's autumn." And that was because her prominent after image, this complementary, in this case seeing green and then perceiving this after image of red, was so strong that it actually made her think it was a different season of the year. She had this sort of blurring together. Another lady who was very confused watching England play football in their white shirts on the green grass of Wembley, because she turned to her husband and said, "Why are England playing in pink tonight?" So these little asides, but which has led us to identify some of these strange and less commonly described features of PCA, which are quite characteristic if you know what to listen out for. Another set of examples of people mentioning things that have come to prove very useful both for diagnosis and for training was one lady who I was trying to administer a verbal memory test to her, in which she had to look at a word on a pad in front of her, or a series of words, and to try and remember them for me. But I showed her the very first word, which I think was sand, and she said, I can see the S, and I can see the D, but I can't see the letters in the middle. And this turned out to be the first time that we had consciously seen something called excessive visual crowding, which is a phenomena that normal healthy people have in their peripheral vision, which is that it's very difficult to identify things amidst clutter. And actually it turns out that people with PCA have this even in their central vision. So when they look, as in these stimuli here, we did lots of experiments in which someone was asked to look at 3 letters or a letter flanked by 2 of anything, and just to say, what's that middle letter? And instead people would often give a response which combined different bits of information from that scene. So it seemed like there was an excessive pooling of information. People would blend together different fragments and come up with an entity which wasn't actually present. And with a bit of careful experimentation, we saw that when those flankers were very close in, and then you get these crowding effects. When you space things out a bit more, the people's error rate drops. They find it much easier to see. So clutter turned out to be, in this abstract scenario, something that was quite important. But I'll go on to tell you a few more examples of where we try to turn that slightly arcane academic knowledge into something that's a bit more useful in everyday life. Another example of a reading relevant deficit was someone who came to Nick Fox's clinic and had talked about this strange story in which he'd been going to work, and he had looked at his newspaper and, to his surprise, noticed that he could read the small print of his story, but he couldn't read the headlines. But then, even more oddly, he looked down the carriage and someone else had the same newspaper and he could read their headlines. Now, if you're in your 40s or 50s and go to most clinicians with that story, I don't think people will be thinking dementia. But what turns out to be the case is, of course, things at a distance or a smaller visual angle. And it turns out that people with PCA have these so-called inverse size effects. So they're better able to perceive things that can be perceived over a small visual area, which don't require multiple fixations, than they are larger stimuli, which to us seem more prominent and easily defined. And that is true whether you're talking about individual letters or numbers or words or other stimuli as well. So this is what we refer to this as sort of reduced effective field of vision. It's not that people are blind in the periphery, but their ability to attend and make sense of things gradually shrinks down. And so only smaller items can get through. And it also means that many typical things people use to be helpful, if you've got someone with a visual impairment, lots of people think, oh, well, we'll just make the text bigger for people, that'll be helpful. And it's actually quite the reverse. It's actively unhelpful. So a couple of quick ways in which this is helpful for training clinicians and helping people to detect PCA. If you think of a standard acuity chart, a large letter at the top For someone with PCA, it's nicely on its own, so you're not going to have any crowding around it, but it's too big. People with PCA can't see that top letter. Equally, if you show them the letters at the bottom together, they're the right size for them, but we've put them in a line by habit. And so they get crowding effects and aren't able to read them that way. And so all you need to do is show letters of the appropriate size, but in isolation. And then you've got an effective test of acuity for people with PCA that they can do, and you can actually understand whether they need any refractory correction or not. And just, I guess, on that score, we've been looking a bit about different cognitive tests that could be helpful for identifying people with PCA, but also which might pick up visual deficits present in people with typical memory-led Alzheimer's disease as well. And just a couple of examples. So tests like acuity, as I mentioned, actually people with PCA and people with AD, very few fail this test. So despite this posterior atrophy, you find very relatively preserved visual acuity, ability to see small things in individuals with PCA, even when they've got very prominent higher cortical deficits. Crowding is pretty good. About 30 to 40% of people with early stage PCA fail that test, but not a single one of any of the people with typical memory-led Alzheimer's disease that we've tested has failed even a single item of our basic crowding test, which presents one letter in between 4 numbers, and you just say, what's the letter? Every single person with memory-led Alzheimer's disease has got those questions completely right. And then there are other tests which almost everybody with PCA is unable to do, and about half of people with memory-led Alzheimer's disease are unable to do things like these fragmented letters tests. Incredibly simple to administer. We're trying to get optometrists to have 1 or 2 of them in their desk drawer just to flick out for people when they think that this might be cortical visual, a brain sight rather than an eyesight issue. And these simple learning tricks, I think, can be passed on. So hopefully more people with PCA find out their diagnosis a little bit earlier in a more timely way. And just to say, there's my colleague Kier Yong, as part of the PIA, the professional interest area I mentioned, he and his colleagues are keen to spread ideas of tests which might be helpful. And this is just one such example from the Queen's Square Stable, a pocket-sized book for £10 that's easily available, which tests a variety of the different visual perceptual skills that I've been mentioning. And also just to encourage you that it's not just psychologists and neurologists who are on the case. So fantastic ophthalmologist in London called Gordon Plant and his colleagues have done a lot of work to try and raise awareness of PCA. And they had these highlighted here, these simple rules of thumb for things that people should be looking out for example, failing the test plate on the Ishihara test because it's a fragmented image, basically not being able to see that irrespective of color vision. And people who particularly, when you're looking at their spatial orientation, are unlikely to have these sort of, as you saw in the earlier video, are likely to make these characteristic spatial errors or misplacements. Or people who, when you're testing perimetry, don't necessarily have a dense hemianopia, but are quite inconsistent about sometimes seeing things in their peripheral vision, but sometimes missing them in a rather, what feels like rather haphazard pattern. Another area to flag up, or set of stories, is bits of research and stories that have led to research that hopefully lead to practical help for people with these conditions. So one of the visual tests, if I just flip back quickly, and that I mentioned, some of these visual tests are quite sort of spatially demanding and cognitively demanding as well. Others are much more simple. This dot counting test here, for example, really is as simple as the label suggests. You just show people a few dots and you ask them to say how many dots there are. But one of the first people I met with PCA, I gave this test. I think there were maybe 6 dots on the page. And the lady just looked at me and she said, "Oh, it's terribly difficult to count them when they're all moving." And I don't live in San Diego. There was absolutely no chance this was due to an earthquake. I wasn't shaking the table. She wasn't shaking. This was, it turned out, her having tiny microsaccadic eye movements of which both of us were unaware. And so this data that you're seeing on the screen in front of you comes from the simplest experiment we've ever run, which is to put one dot on a screen and ask people to look at it whilst we look at their eyes, and I track the movements of their eyes. And as you can see, over time, healthy controls are able to hold fixation on that dot very well. People with typical Alzheimer's disease are pretty good at that task, but a few square wave jerks. People with PCA have some of those square wave jerks, but then suddenly sometimes have these massive saccadic intrusions. Their eyes will just flick to a totally different area of space, entirely unintentionally. No distractions. They weren't planning to look at something else. Their eyes just jump. And I think this is what Benson was talking about, or that Benson's original patient was talking about, when he said that sometimes things seem to just disappear from in front of him. You found what you're looking for, it's right under your nose, and then suddenly your eyes flick off. You can't detect that, you didn't plan that eye movement, and so the lived experience is it's disappeared, or perhaps someone's taken it from me. A simple experiment, but with quite an important truth behind it. Similarly, this is people attempting to do a smooth pursuit task, so a dot just moving smoothly back and forth, left to right on the screen. People with who don't have a cognitive impairment can track that movement very smoothly. People with typical Alzheimer's disease, again, some of these square wave jerks, but they're able to find their way rapidly back to the line. And people with PCA, this is one example, of course, but in a constant battle to keep up with this dot. No ability to perceive the overall pattern of movement, and constantly chasing, almost never, spending far less time actually seeing the dot than they are chasing it. And in terms of practical implications, one of the ways in which we've tried to turn this information into use is because a lot of people are bitterly disappointed that their independent reading ability goes off the boil so quickly. Lots of people devastated that one of the things they cherish most in life, being able to sit and enjoy a book or a newspaper, is gradually getting further and further out of reach. And just as an example, we'd mainly previously done single word experiments in reading before, but my dear friend Keir had the idea to give people paragraphs of text to read. And so this is not actual eye tracking data, this is just tracking whether people, the kind of order in which people read words. Someone with typical memory-led Alzheimer's disease, these nice fluid movements, you get to the end of one line, you flip to the beginning of the next. This is someone with mild PCA. You move on, the X's indicate missed words or incorrect words. These yellow lines indicate where people have jumped on and then are trying to retrace their steps back up, or making erroneous jumps that miss out loads of words where they can't find their way from the end of one line to the beginning of the next. And this pattern up here, the color coding, indicates when overall over a group of people, when we show people with PCA these paragraphs of text, the darker the color, the more likely they are to have read that word correctly. And so I was telling you about crowding earlier on, about one letter flanking another, anything in clutter really getting in the way. And suddenly you see that the areas where the color is the whitest, where there's least accuracy, least ability to read those words, tends to be towards the center of paragraphs, where you've got all this clutter and noise of other words around you, and it's most difficult to pick out the word that you're actually trying to look for. And so Keir developed a task where he just simply said, well, rather than making people's eyes go to where the words are, let's bring the words to where the eyes are. So we created a simple fixation box and presented either one word or a couple of words at a time. And in white, you see how many words people are able to accurately read when you're giving them the normal paragraph format. And in blue, this is the accuracy level when you give either one or two words at a time. So some people trebling their ability to read words accurately, the number of words they're reading accurately. Of course, this isn't a miracle cure, and it's an aid. We're not treating people's visual abilities here. We're just providing a support which enables them to read for longer. But my colleague Ida Suarez-Gonzalez has taken this forward into an app called Read Clear, which is able to grab text from different sources, books, magazines, things people want to read, so they have autonomy and choice over what they read. And while some people do choose to just stop reading and go for audiobooks, there are a lot of people who are making the choice to try and extend the period for a few years over which they can read independently by having this adjustable application that can start by just giving you one sentence at a time and then gradually reduce down to producing a few words at a time, or even a single word at a time, and enable you to have a little bit more autonomy. Okay, 2 or 3 more areas. I hope I'm okay for time, but I don't want to bore you. Just one thing about perspectives. Sonia was mentioning in relation to her and Andy the possibility of dancing and the love of dancing. And one other really striking example of something said that someone with PCA said that caused us to get our research to go off in all sorts of different directions was at one of our meetings. Someone said that her mother who had PCA had recently said to her, "Am I the right way up?" And I'd suggest that unless you've been impressively drunk or perhaps really seasick on a boat, you've probably not had to ask yourself that question before. And it raises lots of interesting questions about, well, how does the brain actually help us to orient ourselves? So we've been doing a series of experiments over the past few years with a wonderful physiologist and movement expert called Brian Day, in which people have done experiments like standing in front of a screen where we rotate dots, where we give some vestibular stimulation to people, or where we just ask them to do tasks like seeing a rod, giving them a knob that controls which angle it's pointing, and ask them to make it as vertical as they can. And in these experiments, just a subset of them on the right, this is about haptic control. So this is in people with PCA and memory-led AD controls, asking people with their eyes closed, so just using the sense of touch to be able to orient a physical rod to vertical. And these are just graphs of the absolute error that people make. And you can see this is a task that even without any vision involved, people with PCA find particularly difficult, but which is also not straightforward for a number of people with typical Alzheimer's disease. So the overall thrust of these experiments is that there seems to be a real disruption because of this parietal atrophy, a real disruption of the mechanism that enables this sort of spatial mapping and transformation of verticality information between different body parts. But I think at a more practical level, it makes it easier for us to understand why, for example, a number of people have said that one of the earliest things they noticed when they were beginning to have some experience of their PCA was changes in things like the ability to dance, the ability to do complex spatial tasks like getting dressed. And for me, it also makes sense, it makes me wonder about the experience of many people with later stage dementia as well, and how much of their behavior is misperceived. So for example, we had one patient with PCA who at quite an advanced stage, his wife said, "Oh, I had a really difficult week because his carers left. They said they wouldn't look after him anymore because he was being violent towards them." This didn't seem to ring true to me. And when we probed a little bit further, it seemed that the carers had been trying to roll this gentleman in bed and had been struck in the face. So for a start, in terms of interpretation, I think if you took someone like the person in the video I showed you earlier on, I would argue that someone with PCA would have great difficulty localizing a face target in space and intentionally hitting it. But I think particularly hearing comments like, "Am I the right way up?" it also makes me think how terrifying, if you don't know which way is up, how terrifying could something as simple as being rolled over in bed actually be? Why wouldn't that potentially feel like falling or some other incomprehensible movement happening to your body that you couldn't control or comprehend? And so perhaps when people in later stage, not just PCA, but Alzheimer's disease and other conditions, we have to have greater awareness of how strange and potentially distorted not just their memory, not just their vision, but some of these more embodied senses and complex perceptual matchings might actually be. I'll skip over that just for interest of time. Another thing where we've really taken a lead from the people living with these conditions is in the changes people have made to their own homes. So several people have kindly shared with us or demonstrated to us when we've gone on home visits, little adaptations and tricks they've used around their homes. So someone who decided after Christmas not to put their Christmas lights away, but instead to see whether they could help be a useful guide up the stairs. And that again has prompted a series of experiments with engineering colleagues into exploring which elements of our household design could potentially be altered in order to improve everyday abilities. So obviously lots of people, acceptability is a big thing in when thinking about design. You can't, it's great to say, oh, we've discovered if you paint your room red and white, red and purple stripes, that will make things better. People won't want to do that. The homes still need to be lived in. But things like lighting changes, the direction of light could potentially be more acceptable to people. So we did, for example, some experiments about how if you illuminate a target with light, does that affect people's walking paths? So this is an experiment in which people with PCA were asked, please can you walk through the open door? And all we changed was which way the light was pointing. And I think you can see from these parts, at least for a number of individuals, this made a real difference. And similarly, shadows, something that often people complain about. People say, oh, that shadow, that mat, that change in floor pattern looks like a hole. I'm terrified of falling into it. And so again, a simple experiment of please can you walk through the open door? And the only thing we changed here was the direction of the lighting. The overall lighting levels were exactly the same. But when you shift the lighting level to create these shadows across the path you were planning to walk on, not in people with typical AD, but in people with PCA, you see all these circles which indicate significant hesitations where people stop. And in people with PCA, particularly before the shadows, as they approach them, where these significant hesitations occur. And some people might say, well, what difference does that make? If you're a bit slow across the room, it takes you a little bit longer, what does it matter? Well, lots of us, you know, if we were going to the Louvre, for example, it might make a big difference. It might be really important. So, but also that broader sense of ease and comfort in your own space. I think if anything we can do that might be helpful to people is worth considering. And also, of course, we've begun to look not just at changes in the physical environment, but also changes in the social environment. So gradually introducing social psychologists to our team who've been doing things like day-long visits with people living with PCA and their loved ones, and to see how they're coping, what sort of changes are important to them, and making sure that as much as possible in every aspect of our work that we're listening to what people say and directing our research accordingly. And just before I finish, I was just going to mention, I wanted to show this photo, which I hope Sonia might recognise, because she once very kindly stood at this same microphone when we were having a Dementia and Arts residency at the Wellcome Collection gallery in London, where we were lucky enough to hold all of our support group meetings for a number of years. And Sonia very generously came and spoke of her experience, and also answered some of our members' queries about dealing with sleep disruption. So again, very much wearing both hats, lived experience and professional, as so many people do. So I won't take any more of your time, just to remind you that I hope you can interpret work that you will fund and support into PCA in your area, not just as being of potential benefit to people living with this relatively rare condition, but of relevance to absolutely anyone with any dementia who may well find that visual changes for them are a case of when, not if, particularly later in the condition. And although PCA is most commonly caused by Alzheimer's pathology, and we need to understand, as you were saying earlier, what are the particular causes of vulnerability and also potentially protection? Is this pattern emerging because some parts of the more typical AD cortical structures are relatively preserved in people with PCA, not just the back being more vulnerable. We don't see much evidence so far for kind of distinct PCA subtypes, but certainly variability is very, very pronounced. And I think you will find that, as you probably have already, that people with PCA you work with will be as varied as any of us. It's quite a heterogeneous condition. I hope I've managed to convince you that really listening to people and really taking seriously what they say can be often the best, most enjoyable and exciting and rewarding of starting points for research projects. And that will also be a gradual enriching of the PCA literature, so we talk less and less of it as being the canonical visual dementia, and also recognise in more detail all these other non-visual aspects of the condition. So many thanks to the many people who've been involved in all the work I've been talking to you about, but particularly my dear friend Kia Yong. And also just a reminder that anybody you see with a PCA who might be interested to meet other people with PCA, there are a few PCA support groups around, notably in Colorado, nearest to you, but anyone from anywhere in the world is welcome to join us at Red Image Support for online meetings and to seek information, and also a variety of other courses where we've tried to explain a little bit more to different public audiences about some of these rarer types of dementia, including PCA, which would be happy for you to look at or share if that's helpful. Anyway, I shall be quiet for now. I'm very happy to take any questions. Thanks for your time.